Hello and welcome to Math with Mrs. Becker. Today in Algebra 2 we are going to start Chapter 6. So looking at 6.1 we will talk about something that are called polynomials. Now first off, in order to make a polynomial you need a monomial. These are examples of monomials. Mono means one. So you have one single term, meaning you are not adding or subtracting anything, but your monomials, they can be numbers with letters, you might have exponents, but again, it's one single clump. A polynomial is a monomial or a sum or difference of monomials. So if I wanted to take these and turn them into a polynomial, I could just put plus or minus signs. And if this was all together, that's what a polynomial is. You are adding or subtracting monomials together. Every single monomial, or monomial in the polynomial is called a term. So this, if I put those plus and minus signs, this would have 1, 2, 3, 4 terms. Again, a monomial only has one term, so it is the most simple polynomial. Okay, there are some rules of polynomials. You will never have to be able to state the rules, but it's kind of cool for you to know things that you will not see in this chapter as we're studying polynomials versus things that you will see. When we are looking at polynomials, you will never have variables or exponents in the denominator of a fraction, okay? So this is not a polynomial because there's variables on the bottom. You will have no negative exponents because remember, negative exponents would put that on the bottom of a fraction. You would have no roots, whether they're square roots, cubic roots, fourth roots, or absolute values of variables. So you won't have this, you won't have this. Every variable will have whole number exponents, so you can't have an exponent that is a decimal. Okay, so these are not polynomials because they do not follow the rules. These are examples of what we will have. Your exponents are going to be whole numbers. Look at that's a polynomial. This is a monomial. This is a monomial. You can have fractions. You just can't have the letter on the bottom, but you can always have numbers on the bottom. You could have decimals, just not as exponents. Notice here the exponent is an integer. Okay, it is that whole number. Then again, this would be a polynomial because you're taking two monomials and subtracting them. The first skill is kind of cool. If you want to find the degree of a monomial, remember monomial means one piece, you just have to ask yourself, how many letters does this piece have? Now z to the power of 6 is really 1, 2, 3, 4, 5, 6 z's. That's what z to the power of 6. So if you are finding the degree, you're answering the question, how many letters does this have? 1, 2, 3, 4, 5, 6. So this is a degree of 6. 5.6, if you're asking yourself, hey, how many letters does this have? Well, none. There are no letters in 5.6. This would be 8x y to the power 3 means 1, 2, 3 y's. So the degree, how many letters it has, it would have 4 letters because it has 1x and 3 y's. A squared, b, c cubed. This monomial would have a degree of 6 because it contains 6 letters. X cubed would be 3 because it actually means 3 x's. 7. There are no letters in the number 7. This would be 5x cubed y squared. There are 3 x's and 2 y's. So 3 plus 2 would be 5 variables total. This is 6 A's, 1 B, and 2 C's. So 6 plus 1 is 7, plus 2 more. There are 9 letters. The number of letters in a monomial, when you're looking at just one term, the number of letters you have is called the degree. Let's keep on going. If you want to know the degree of the polynomial, what you do is you find the degree of each monomial. So you go one term at a time, okay? Figure out the degree. Whichever has the greatest degree, it's kind of like that wins, and that becomes the degree of the polynomial. So for example, this has 3 variables, this has 2, this has 1, this has 0. So the degree of the polynomial would be 3 because that is the largest. Okay, so please make sure that you're not accidentally adding all the letters total. You find each degree separately. Biggest one becomes the degree of the polynomial. When you have a polynomial that only has one variable, so it's only x's, only y's, like we have here, okay, all of the variables just an x, you always want to write it in what's called standard form. Standard form means that you go from the largest exponent to the smallest exponent. When you have it in standard form, then you can identify a lot of cool things. If it's written in standard form, the leading coefficient, remember a coefficient is a number in front of a variable. The leading coefficient would be the number that leads the whole problem, as long as it's in standard form. So here our leading coefficient is 5. If it's in standard form, the degree of the first monomial is going to be the degree of the polynomial. Okay? When we are writing polynomials and working with polynomials, you can name them. There's 2 ways that you're going to name them. One of them is based off of the degree. The other one is based off of how many terms it has. If you have a polynomial with 1 term, it is a monomial. If you have a polynomial with 2 terms, it's called a binomial. So kind of like a bicycle has 2 wheels, a binomial has 2 terms. A polynomial with 3 terms is called a trinomial. Just like a tricycle has 3 wheels, a polynomial with 3 terms is a trinomial. After trinomial, what you would say is polynomial with 4 terms, polynomial with 5 terms. Okay, so there's only a special name for 1, 2, or 3 terms. After that, you just say it's a polynomial with however many terms. The other way that you can classify is by degree. Remember, degree is how many variables you have in, or the greatest amount of variables in one term. So if I had this has a degree of 0 because there are no variables. If your degree is 0, its name is constant. This, the highest degree is a 1. So the degree is a 1. If you have a degree of 1, it's linear. If your highest degree is 2, it's quadratic. 3 is cubic. 4 is quartic. 5 is quintic. After 5, you would just say 6th degree, 7th degree, 8th degree. But there are special names all the way up and through 5. So let's go ahead and put some polynomials in standard form. So the first thing we want to do is write each polynomial in standard form, okay? So we'll go ahead, and the highest exponent must go first. The highest exponent is a power of 2. Remember, a minus sign is always tagged with whatever's behind it. So this would be negative 5x squared. Now from what I have left, the highest amount of variables is 4x, followed by 3. So that is standard form. 2x's, 1x's, no x's. The leading coefficient, the number in front, would be a negative 5. The degree, the highest exponent, is a 2. The number of terms, 1, 2, 3. Now you name it. Okay, so it goes degree terms. My highest degree is a 2. If your degree is a 2, it's quadratic. My number of terms is 3. If it's 3 terms, it's a trinomial. So this thing is a quadratic trinomial. Okay, let's look at another one. Highest exponent is a power of 4, so it's 8 to the power of 4, plus, then it would be 3x squared minus 4, so that's standard form. Your leading coefficient is the number in the front, so it's an 8. The degree, the highest exponent, is a 4. Terms, 1, 2, 3 terms, so its name, the degree is 4. If you have a 4th degree, it's called quartic. So kind of think like there's 4 quarters in a dollar. So it's a quartic, 3 terms, quartic trinomial. Okay, a couple more just because this is new. If I am rewriting this in standard form, negative 2x squared would come first because it has the most variables. Then 4x, then 2. 2x's, 1x's, no x's. Leading coefficient, the number in the front is a negative 2. Degree, the highest exponent is a 2. Terms, 1, 2, 3 terms. The name, If it's a degree of 2, it's quadratic. 3 terms, trinomial. And last one. If I'm putting this in order, the highest exponent is a 3, so x cubed comes first, then a negative 18x squared, followed by 2x and a minus 5. Okay, so 3x's, 2x's, 1x, no x's, so it's in order. Leading coefficient. My leading coefficient would be an unwritten 1. Okay, there is always, if you have a letter without a number in front, remember there is technically a 1 there. Degree. The highest exponent is a 3. Terms, 1, 2, 3, 4 terms. So its name. It's a degree of 3, so that's cubic. Now if it's 4 terms, remember there's special names for 1, 2, and 3. As soon as you go over 3, you just simply say polynomial with however many terms. So we have a polynomial with 4 terms. Okay, so that's standard form, leading coefficient. You can add and subtract polynomials. When you are adding, what you're basically doing is just combining like terms. So if there's a plus sign in the middle, that plus sign actually won't change anything. So if parentheses kind of make you nervous, and I know that's kind of a common thing, you could go ahead and rewrite it without parentheses. If there's a plus sign in the middle, drop the parentheses. Now you combine the like terms and put it in standard form. So the highest exponent I see is a 3. This is 2x cubed. This is 1x cubed. 2x cubed and 1x cubed makes 3x cubed. X squareds. I have one term with an x squared. That must come next. Negative 1x and positive 7x makes 6x. Positive 9 plus 4 is 13. Standard form. Now, if it's a minus, the negative goes into all of the terms of the second group. So the first set of parentheses remains unchanged. But now it's negative x squared. Negative times a positive is a negative 6. Negative times a negative is a positive x. Now we go ahead and write it in standard form. The highest exponent is a 2. Negative 2x squared and negative 1x squared makes negative 3x squared. So I got those. Next highest exponent is x. Then negative 6 and a positive 3 is negative 3. Here's another one. If there's a plus sign, if you have a plus sign, you can simply drop the parentheses. Now, combine like terms. Again, you want it in standard position. So the highest exponent goes first. The highest exponent is a 3. So 16x cubed goes first. This has 2 x's. This has 2 x's. So you combine the like terms. Negative 36x squared plus 6x squared is negative 30x squared. Got those. Next highest exponent would be a 6, or 6x, because it's just a single x. My constants, so numbers that do not have a letter, go at the end. Negative 11 minus 5 more is negative 16. One more problem where we'll go ahead and subtract. Remember, when you are subtracting, the negative sign goes into the second set of parentheses. 5x cubed plus 12 plus 6x squared. Negative times a positive makes this negative 15x squared. Negative times a positive makes this negative 3x. Negative times a negative would make that a positive 2. Now we combine like terms and put it in standard form. So the highest exponent is 5x cubed. This has 2 x's and this has 2 x's. So we go ahead and combine them. 6 minus 15 would be negative 9 x squareds. Then I'd have minus 3x. 12 plus 2 is 14. So adding and subtracting polynomials. Another thing is you can use polynomials to evaluate story problems. It says the cost of manufacturing a certain product can be approximated with this function, which notice it's also a polynomial. X is the number of units of the product in hundreds. So when it's a 1, it's 100. When it's a 5, it's 500. If you want to figure out the cost, you can just replace the x with a value. So if they want us to find the value of making nothing, making 0, we could go ahead into the function and replace the x's with a 0 and evaluate it. So here I end up with just 45. So what does this mean? It costs $45 even if we don't make anything. Because that would be things like maybe you have to pay rent on the machinery and electricity for the building that you're renting, that sort of thing. So a day where the manufacturing plant is closed so you don't make anything, it's still costing the owners $45. Let's say that x is 200. So 3 times 200 cubed minus 18 times 200 plus 45. So I'm grabbing the calculator for this one. 3 times 200 to the power of 3 minus 18 times 200 plus 45. So wow, this is big. 2, 3, 9, 9, 6, 4, 4, 5. So it's 23,996,445. What does this represent? This represents the cost of doing 200 hundreds. So you would add 2 more zeros. So when you have 200 hundreds, you actually manufactured 20,000 of whatever the item is, okay? So you can use polynomial functions to describe real-life situations. All right, last idea for the day. Throughout this chapter, we're going to learn skills for analyzing, describing, and graphing higher polynomials, okay? But until we learn a lot of those skills, we're going to use a graphing calculator. Remember Desmos.com. Free graphing calculator. It's awesome. So as you're doing the assignment for today, go on to Desmos.com to do your graphing. Once you graph, okay, they want you to graph each polynomial function on a calculator. For your assignment, when you get to those, you'll have to sketch the shape, okay? Just to save us time on the notes, I went ahead and included a visual for you. Then you're going to describe the graph, and you can describe it any way, okay? There's not a right or a wrong answer here. And then tell the number of real zeros. Remember, zeros tells you how many times the graph touches or crosses the x-axis. So here's an example. If I graph 2x cubed minus 3x, this is what the graph looks like. If you're describing it, you could say, okay, I'm going from left to right. The graph increases, then it decreases, then it increases again. It has 1, 2, 3 real zeros because it crosses the x-axis 3 times. Okay, if you graph negative 1/6 x to the power of 4 plus 2x squared minus 2, this is what it looks like. You could say it increases, then decreases, then increases, then decreases. Or you could say it looks like the letter M, because that's the first thing I think of. Or you could say it's the McDonald's arches. It just says to describe the graph. So you could be as technical as you want. Then you have to say how many zeros you have. How many times does it touch or cross the x-axis? 4 real zeros. And it's important that you say real because remember, we can have imaginary solutions that maybe we can't see at this point. Okay, so this one has 4 real solutions. If I graph 3x squared minus 2x plus 2, this is what the graph looks like. This is a parabola. Or you could say it's a U-shaped graph. Or you could say it's a smiley face. You could say it decreases and then it increases. Any of those things are okay. How many real solutions? How many times does it touch the x-axis? Never. So this has no real solutions. Last one. When you graph this polynomial on a graphing calculator or Desmos, your graph will look like this. If you're describing it, you could say decreasing, increasing, decreasing, increasing, or you could simply say, hey, this thing looks like a W. How many real zeros? 1, 2, 3, 4. It has 4 real zeros. That is section 6.1. It is a book assignment for today. You're going to start way up at number 19. So go ahead and head to the book, and you are doing numbers 19 to 40 and number 45. Hope you enjoyed our time together today, and I'll talk to you soon.